I'm Kelly Fitzgerald, and this is Ryan Fitzgerald. We both graduated from Kettering 5 years ago. Six for him. We've been mentors on 314 the last few years. And of course, we help with the programming. So how many people who have programmed at all before? All right. So what our plan is today is we're going to go over some of the basics of just programming in general. Variables, if statements, loops, everything you need to know if you're going to get started in a written language. Then we're going to work on getting code actually downloaded to your robot. All right. So go to the first thing we just wanted to mention is why use C++. I don't know, has anyone used LabVIEW or Java? Okay, quite a few. C++ and Java, they're both written languages. LabVIEW is very visual. If you want to go into computer programming, it's really good to get experience in a written language, especially object-oriented. Java is one of the most used languages in general. C/C++ is used a lot more in embedded systems, although you see it in other things like, what is it, the iOS app programming?
Yeah, Windows was programmed in C or in C. Yeah.
So I got my degree in computer engineering, so I like processor level programming. And that's why I like C++, but it's not always the best language for someone who's a complete beginner. We'll go over this later. This is mainly just reference material for when you want to install Eclipse on your own computer. There's a couple steps that first has you do to get the WPI plugins. Who knows what a variable is? Hey, a couple people. All right. Basically, it's a way to store information in your program. Right, so variables are a way to store something in your code, and there's different types, like an integer, so it can be a number. So if you want to count something, you can set it to 1 and then increase that value.
But it's a number without a decimal place. There's no number between 1 and 2.
In an integer.
Mm-hmm.
So yeah, you have your different types. Integer, that's just 1, 2, 3. Floating point number with a decimal, so you can do things like pi, because pi is good. A Boolean, true, false. That comes in handy a lot. Strings you really won't use in FRC, not really. And objects and pointers are a little bit more complicated, but we'll
get into that later on in the presentation.
That's a lot easier to show you an example of. And then arrays are really a list of values. So
they're a list of the values of the same type. So
multiple integers in one array. Operators, this is where you get into your equals, doing arithmetic, addition, subtraction.
Basically, an operator does something with variables. Very generic because there's a lot of different operators that do a lot of different things.
Yep.
So
yeah, your first ones are pretty simple. You've got your arithmetic, addition, subtraction, division. What's it called? Modulo?
Modulo.
Which is the remainder, which is useful.
A lot of times where that's very useful.
Yeah, especially if you ever write a program where you're doing like a clock. That's when you get remainder in there. Comparison, not spelled right. So comparison, we'll get into later when you're you want to see if something is true, you can do an equals equals. So if you want to see if your value count is equal to 1 and you want to do something. Or in FRC code, it's usually, hey, is this button pressed? That's where you get your equals equals or your not equals. Is this not pressed?
And you want to be sure it's 2 equals actually does a comparison. A single equals actually copies the value from one variable into another. So, something you got to be kind of aware of, because you might overwrite variables accidentally in the middle of your code if you only use single equals.
So that's a quick way of not using an if program.
You still, it's what you use inside in an if.
Yeah.
It's used in your conditional statement.
Yeah.
But yeah, so these are your comparison, and then logical. So you can do ands, ors, or not. So you can say, hey, if this is true and this is true, then do something. Or if either of these conditions are true, then you go and do your code. And that will make, these are just a few additional ones. Easy ways to add something to a variable. Plus equals, you're adding whatever is in the variable plus, yeah.
There's a lot of times where you want to add something to an existing variable and then store it back in itself. These ones do it without having to take a lot of the code out of that, making it simpler. We're not going to go too in depth to this. We just pointing them out because
you don't really need this. It just makes your code shorter by a few characters. All right, so conditional statements, this is where you're going to use those comparison operators. So you'll have an if statement, and it's basically, hey, if this button is pressed, then run this code. And that's how all human control is done. If else is another type of if statement. And you have if else and if else. So you can say, if this button is pressed, else do this. And an if else will let you go through multiple things, so that if 2 buttons are pressed at the same time and you have an if else, only the first one will evaluate to true. Loops, this is a way to loop through the same segment of code multiple times. While statements, when we open the sample robot code, your teleup code is within a while statement, and basically all it does is it continuously runs the code as long as you are in operator control, not autonomous, and enabled is true. So it'll continuously run as long as the robot's enabled. And then a for loop, the other one we're going to mention is a for statement. That's used to count through something. So if you want to count through 1 through 100 of a variable, it's very easy to do that with a for loop. So you have the while loop I was talking about. It's basically while operator control is true and is enabled. And those are both WPILib functions, so you don't have to worry about what's in them. You can just put is enabled and it'll work.
The robot,
it's something FIRST provides.
yeah, the WPILibs keep track of whether you're in operator control mode or part of the competition or the autonomous part of the match. So you can, you don't stay in your autonomous code when you get to your operator control portion of the competition, because that's bad.
What's WPI?
WPI is Westminster Polytechnic Institute. They put together a set of libraries for FIRST when they first went over the C Rio in 09, and they've updated them, and now they've ported them over to the Robo Rio. So when we say WPILibs, that's their libraries for both C and Java to provide all the functionality for interfacing with the controllers.
Yeah, and it gives you a lot of, I mean, FIRST already provides the basics. Like all you have to do to make a new motor is say, hey, you know, I'm going to use this motor object.
You tell it what port it's
and you tell it what port it's on. So FIRST does a lot of the work for you already. So this is a good example of both an if statement and an if else. What code was this? This was our bumper code.
Yep. We check to see if the shoulder buttons on the controllers were being pressed. And if it was one way, we reduced the speed. If it bumped the other way, we bumped the speed up a bit.
Yep, so when you see like if
Here, let me scroll up a little so we can.
prime left bumper, that's a map to a joystick button. And basically it's either a 1 or a 0. If the joystick is pressed, it's 1. If it's not, it's 0.
So what did your robot do during that time? I mean, what
This-
was it trying to decide? You say bumper, what is a bumper?
It was
shoulder
the-
buttons on. That's what we called the shoulder buttons on the controller. So this here we were increasing and decreasing our speed, allowing the driver to increase or decrease the speed of a control with a button, so they can increment it up or increment it down.
Or is it going up and down with the toes?
Yes. So they press it once, it jumps up. It goes to one position up.
So in that programming, you're programming which button you want to do what?
Yes.
At this point, we've already read the value of the controller into those, and now we're just in this if statement checking to see, okay, was this button pressed?
Yeah, basically what we're doing is, so what I'm trying to show you is the if statement. So we're saying if a button is pressed, then it executes the code in here, which says go to the next lip height. If the button's not pressed, it completely skips over this statement. So that's why we call it a conditional, because it only executes if a certain condition is met.
So the else if goes with the second if.
Yep.
Yep, and that's saying if the first one's not pressed, then check the second one. If the first one is pressed and you get into that code, it doesn't
Never
even
runs
look
the
at
second
this. It never runs the second set of code. And that's a precaution in case someone jams down the buttons and they're pressing 2 at once.
It doesn't try and go down and back up immediately.
Yep.
It ignores one of them if the other one's pressed.
Yep, and there's also, you can do an if else without the extra if on it. And what an else statement does is if the if statement condition is not met, it automatically goes into that else statement. So it's if this happens, do something. Else, do something else.
Reformatting this to make it look nice.
Parentheses or whatever they are. You're basically putting what you're looking at.
Yeah. Right now I'm just trying to make
So the brackets are what tell you what code you execute
Yep.
when the if statement is true. So anything within those brackets gets executed.
So if this statement, if the left bumper and the right bumper are not pressed, it will run everything between these two parentheses. And then the next one here says, okay, if the left bumper was pressed, it runs everything between those two parentheses. If it wasn't pressed, it runs everything between those two.
So it's very much like BASIC,
Yes.
Yes.
only it doesn't have line numbers. So how does it know where to go if you want to go down to the next one?
Compiler knows, looks for the next parenthesis and says, okay, if I'm not doing this, I just jump to where the next parenthesis is in the code. The compiler does a lot of the work for you.
Just gotta keep them matched up.
Yep.
Yep, if you don't keep them matched up, you're gonna have errors.
But as you can see, Eclipse is helpful. And see, I took a parenthesis, don't have matched up parentheses, and it's saying, okay, there's something wrong here. Give me all the little lines saying it's wrong.
All right, and hspeed is actually a good example of a variable. It's declared right here, and it's a float. Why is it a float? Anyways,
Eve decided to make it.
it really needs to be an integer, not a float, because we're incrementing it by 1, so you're never going to get a decimal point.
That's what that is.
But
that was for the H drive.
Okay,
that never ran.
got it. And this is why you comment code, so you know what it does, 9 months later.
So she mentioned comments. If you see the little green slashes, the green text with the 2 slashes in front, the compiler ignores that line. If you see it's the 2 forward slashes, it ignores the text after it. So it's a handy way to put notes in your code of what something does. My opinion, you can never have too many comments. Someone will someday come up with me with an example of too many comments in a program and prove me wrong, but I have yet to see that.
Yep, and comments, yeah, basically all you're doing is saying, hey, this portion of code does, and you tell it what it does. That way, when you come back to it later, you know why you programmed it that way. And while talking about variables, like this H speed, okay, so that was for an H drive, which didn't actually work, but that's the reason we call it H speed. Always name your variables something that makes sense. If you're using the left motor, call it, left drive or left motor. If you're doing it for an arm, call it arm motor. Don't call it Bob or
F or
donut. I've seen someone call things like I want this variable to name donut. Well, you can name it that, but you're not going to know what it means later on when you go to debug it.
Donut.
Unless that. I don't know if I've seen a part called donut yet, but.
We named our arm motors. I think they were named like something. They had female names. It was like one was this.
Nice.
if your team wants to give weird names to your robot parts, and feel free to put weird names in your program that match.
Just make sure things match. You want to know what it does later. That's key. Okay, there we go. It's a little bit. This is a for loop that I was talking about. Basically what it is you're starting off with an integer value of 0. And then this statement here increments it by 1 each time it goes through the loop. And this statement says if that variable is less than, we're going to say 10. I'm not sure what update count is defined up in the top of the program, but so it's going to loop through that 10 times.
The key difference between a for loop and a while loop, for loop, you have a predefined set of conditions where it will run through a certain number of iterations. While you can make a for loop be a little less strict in how it runs, usually they run. So this is a very common way to use it. You have a counter variable that counts through a certain number of points, and then it ends. While loops, they'll keep executing until the condition here is met. So in here, until operator control or is enabled, or either of those go false, it'll just keep running that. They can run that indefinitely. The nice thing about for loops is they're fairly safe to have in the middle of your code. You won't have a loop that just runs on forever in the middle of your code, not letting any other code to run.
So your variable update is something you defined earlier, we 10 to 20.
Yep.
If you didn't want to use update, you could actually use the number 10.
Yes.
What it is
Save you time.
Yeah. We declared a variable at the top called update count because we didn't want to have to search through the code at every location that we wanted to have this count updated and fix it. So we just put a variable at the top and set it to 10 or I think 5, something.
Yep.
All right. So I think that's everything we've talked about so far. So let's get back to the presentation here.
You guys have questions?
Yep.
Yeah, feel free to ask. If we're going too fast or
We're trying to get
too
through
slow.
this the presentation here so we can get you guys programming because, well, I know it's boring sitting watching a presentation about programming and, well.
I just want you to have some of the terms when you start looking at it. All right, so the next topic we just want to brush on is functions. And basically this is a segment of code that can be reused. So you can write a set of code like set motors is one that we used. And we call that several times in our code. And then if you ever want to change what you're doing with the motors, you only have to change it in that one function. You don't have to change it everywhere in your code.
Yeah. Like, say you start out with only 2 motors on your drivetrain, one on the left, one on the right. So you have one set motors function, and you set the left and right accordingly. You say, okay, the build team decide, we don't have enough power in our drivetrain. Let's throw 4 more sims in our drivetrain. So now you have 6 motors in there. So instead of going through your code everywhere in your code where you had to set your motors for something, you just go to your function there. You just add a couple more motors in there, set their values accordingly, and everything you just recompile and it will just work.
So functions basically are what we used to call subroutines, and
Yes.
Lego used to call blocks.
Mm-hmm.
Yep, they're exactly the same. It's just a different term in C++. There's a couple other things here. Prototypes, we'll show you an example in the code. Basically, that's defining your function at the top of the program. Because the way C++ reads code, if you don't have a prototype, you have to write out the function before you use it in the code. A prototype means you can use it anywhere without having to worry about that.
C and C++ are very naive in how they compile their code and look through the code. They go from the top to the bottom, and if they find something they haven't been told about yet, they will throw an error when they're compiling. Even if you have it defined you have the function further down in your code, if it hasn't encountered something saying this exists in this program, by the point it gets there, it'll throw an error and won't compile.
All right. And then the other thing is scope, which I'll show you an example of. Basically, when you're declaring a variable, if you declare it in a function, it's local to that function. You can only use that variable in that function. So you're not going to be able to call that variable somewhere else in your code. You'll have to call the function.
When it returns from the function, the computer will actually release the memory that variable was stored in and allow other parts of the program to take over. So that variable doesn't even exist in the computer anymore when returns.
So by scope, you mean, you're talking about the scope or the usability of the variables?
Usability of the variables, yes.
Really, the nice thing about C is anywhere there's a break, you can only use the variable in the section of braces that you declared it.
Can you declare it at the beginning?
Yes, you can.
If you declare it at the top outside of any braces, that's called a global variable, and it means anywhere in that program then you can actually use that variable. But it means you can't reuse that name anywhere else in your code. So pointers are a reference to a location in memory. So it's basically a variable that tells you where another variable is located.
All right, C++ is the only language you have to worry about, at least for FRC, that you have to worry about pointers in. Java does all that for you. But yeah, when you're making, how do I explain it?
So they're basically giving you an address.
Yeah, it's you're pointing to something. So when you pass that into a function, you're not making a copy of it. You're literally telling it, hey, it's here in my program, or it's here in my memory.
This way you can tell a function, instead of here's a value, here's the location of my value. So then the function has access to, can actually write to that location instead of just saying, looking at the value. The next topic is where pointers actually become quite useful.
Actually, let's just skip to the example and talk about this in an example, because it doesn't...
All right. One thing you'll note, pointers are defined by the little star symbol there. As you can see, everything in here was a pointer to...
And yeah, this is where you get into objects. It's a complicated topic. Okay, so these are all WPI lib. These are all things FIRST provides, like Victor. That's a type of speed controller. So if you're going to use Victors, all you have to do is say
Create a Victor object.
Victor object. So Victor, and there's our lift motor. And the star means that it's a pointer. So we created a Victor object called lift motor, and anywhere we use it in a code, we're pointing to where it is in memory. As long as you sort of understand what a pointer looks like, it's okay if you don't understand really what's behind it.
Oh. And when she mentioned an object in C++ and pretty much any object-oriented programming is a collection of variables and functions that operate on those variables.
But, so we defined the variable up top. We said we have a Victor left drive. And now here's where we initialize it.
Yeah.
And this is where it's actually created in memory. So when we create it, here, like, it's Victor 5. So that's why when you say new, you're telling it, hey, I'm going to initialize this, and we're using PWM 5. So that's how you assign it to what port you're using on the RoboRio. Each of these objects, they have different functions you can call within them. So like a Victor, you can do a set motor. So you're saying, hey, I'm going to set lift motor to 1, which would be full speed.
Yep. Full speed forward.
The example here is your main compressor, which we're setting to true, which just means we're enabling the compressor to be used in this code.
Now, one thing I'd like to mention, you see where we have all these news in here. That's what we were talking about, dynamic memory. That is, when the program runs, it gets to here and says, okay, I'm giving you more memory for this new object you're creating. This is another area that C++ is different from Java. Java, you just create the variable, the virtual machine in the background does all the work of doing all that. Here, we have to create the memory, and then we have to destroy it later if we when we're done with it. When the program is done, the operating system will recover all the memory from the program. But say you created an object and then stopped using it halfway through the program, and you keep doing that, if you don't delete it somewhere along the line, it will get what's called a memory leak, and over time your program's memory usage will grow and grow until there's no more memory to use, and everything will crash. Either the program will crash or everything will crash.
It's not something, if you don't do it in FRC, it's not that big a deal because you're turning off and turning on your controller every 2 minutes.
Yeah, you run for maybe 3 minutes at a time.
It's a bigger problem if you have PC programs that are doing it.
That's really one of the key differences between between Java and C++ is Java, you don't have to Java, they have what's called a garbage collector that takes care of managing. If you no longer are referencing a variable in your program, it takes care of returning that memory to the operating system as needed. Here, you're all on your own. So there's a lot of flexibility it allows you to have, but it also allows you to get yourself in trouble very quickly if you're not careful. So.
Now, those encoders, are they quad encoders because of the 6 and 7? You have to have two?
Yes, that's why they're
yeah.
two numbers. This is a lot more complex code than we will be working on later. We had a lot of good examples already in here. No, we didn't want to write a brand new one for this. So. And another thing, you notice we have the little arrow right there, the minus and the greater than sign. If you're dealing with a pointer to an object, that arrow tells it that you're working with the object that the pointer refers to. If you use the dot, it'll try and use it will try and treat that as a variable instead of a pointer to it. And you'll get error. So, all right.
I know that was a lot of information. Does anyone have any questions before we start actually writing code?
Is there a debugger for something if you have a problem with your program? You run a debugger, or do they not have those anymore and it automatically does it for you?
They do. There's a couple.
Yes, I've never actually set the one up with the clips on our robot. I usually just use print commands to the console, and wherever I'm having an issue, I print a few statements and check to see what it prints out on the net console program they first provides.
It will also show you when you go to build it and download it, if you have any compile time errors, like you're missing a semicolon, then it'll yell at you. So it'll catch any of those mistakes.
So you don't get a compile listing that shows you errors?
Oh yeah.
Yeah, you do.
Yeah.
Yeah.
Already found that I have an error there because I'm missing a semicolon. I was expecting one there.